All right, hi everyone. I'm Craig Kerstiens. I work at Heroku with Terrence and Richard. I run product for our data team there and our languages. I've done a variety of things there. If anyone wants to talk about product at Heroku, which is basically I describe as doing whatever the engineers don't want to do, happy to chat about that afterwards. Really quickly, a few just shameless plugs to start with. I curate something called Postgres Weekly. It's a weekly newsletter full of like end user tips for Postgres, so not targeted at DBAs. I blog a good bit around Postgres, Python, which most of you probably don't care about, and some other things. Postgres.app. There's a lot of Macs in the audience. If you have Mac ports or Brew for Postgres and you have problems with it, because you will, swap to Postgres.app. It's like a nice native Mac installer. And then, as I said, work at Heroku. We run a few Postgres databases. We've said publicly we're the largest fleet of Postgres in the world, and no one's disputed it, so we're going to keep saying it. I had to drop this in after a conversation at dinner last night. How many people here know who Tom Lane is? See, like 3 hands. So Tom Lane has wrote a lot of software. There was a survey in like 2000 and he was responsible for like 1% of open source in the world. He was on the committee for TIFF. He co-authored the spec for JPEG and wrote libjpeg, co-authored the spec for PNG. And then for the last 15 years, he's been probably 50% of every Postgres release. And this is an email from about 10 years ago of him on the mailing list. The short of it is it's Postgres or PostgreSQL. And he essentially said the PostgreSQL rename back in '96 was probably the biggest mistake that the project has ever made, which probably still holds true. So it's not Postgre, it's not Postgres SQL, it's just go with Postgres. It makes life easy. So I give a lot of talks on Postgres. I usually put up a slide like this. How many people here don't use Postgres? A few hands, okay. So I probably won't convince you in this talk, but if you need convincing, this is the reason why. And this is probably missing quite a few things now. If you want it in quote form for Twitter, this is a colleague's quote. I'm not an Emacs guy, but it's really flexible. It does a lot more things than just be a relational database. It's becoming more of a data platform than it is of just a relational database. But kind of on to the topic of the talk around Postgres performance. I assume those that everyone else is a Postgres user, a fan that didn't raise their hand. So Postgres or databases and workloads I kind of group into 2 forms. So there's OLTP and OLAP. OLTP, pretty much web apps. Transactional workload. I assume that's what most people are here doing. Is anyone doing crazy kind of BI reporting, data warehousing stuff? A few hands. So sorry, I won't have a ton for you. I'm catering to everyone else. On setup and config, because usually this is where people start. And I'm just going to breeze through this because basically you do it once and then you never have to care about it again. So if you're running on Amazon, the short of it is use Heroku or take a look at this talk. PostgreSQL when it's not your day job. Amazon is sort of hardware. It's virtualized, unvirtualized, so you treat it a little differently than you would for other clouds. If you're on other clouds, look at PostgreSQL when it's not your day job. It's a great talk by Christoph Pettis that basically is like, hey, go through and set these 50 configs and then you're set. Don't worry about what they mean. They're perfectly safe, just set them, which is a great marketing for me because, yeah, Postgres isn't fun to set up initially. And if you're on real hardware, there's a book, High Performance PostgreSQL. It's by a former colleague, Greg Smith. It's a little old now, about 3-4 years old, but it's still really applicable. He's working on updating it to a newer version. Here, if you have things like SSDs or Fusion IO, he really digs into how you want to tune and optimize it. And there's a link to the talk as well. But if you search for it, PostgreSQL when it's not your day job, if you're running it yourself, that's where to start. So the first time I look at any database, sitting down with customers or one of my own, saying how's it doing, I look at the 30,000 foot view. And the number one rule kind of Postgres is your cache, your memory. Postgres is going to be better at keeping things in cache than you are. I know you think you'll know better, you won't. Postgres basically will keep frequently accessed data in memory and serve it from there. And what I've found is most of the time data is going to follow that 80-20 rule. So you're going to have about 20% of your data, maybe 10%, but a small amount of your data that's really, really frequently accessed. And Postgres is going to keep this in memory. So you don't need, enough RAM to match the total size of your database, just enough RAM for whatever you're using. This varies application by application. So the easiest way to grab this is just run this super simple query. And it's going to give you back something like this. Essentially what you're aiming for is a cache hit ratio of 99% or higher. As soon as you drop below that, performance really, really starts to tank. So at that point, the easiest way to fix it is throw more money at the problem. So give the box more RAM. Another big factor is index. So are you using indexes or not? Here's a little bit of a simpler query to give you your index hit rate. And it's going to give something that looks a little bit like this. So on indexes, I wouldn't encourage that you need to see like a 99% everywhere here. Kind of rough guidelines I would say is your cache hit ratio, you always want above 99% as much as you can have it. Your index hit rate about 95% or higher. If I go back here, you can kind of see there probably the top two absolutely. There's quite a few rows in those tables and never an index that's used. So there may be an index, but it's not used. So you can also have a query that'll search and show you unused indexes and just drop them. But here, rough rule of thumb, I would say there's no indexes there. They're not being used. There's over 10,000 rows. Go ahead and add one. We'll get into kind of how to look and find where they go and that kind of thing in a minute. So a couple of shortcuts. Those queries, you can find them on my blog. You can find them if you're a Heroku user. There's a command line extension called PG Extras that gives you a whole lot of extra commands. So it basically runs these queries for you, so you don't have to know them. You can view the source and just grab all those queries there. If you're not on Heroku, how many people here have a pSQL RC? 1, 2, 3. Okay. Not nearly enough. It's super handy. You can do all sorts of things. All of these things are incredibly useful. The XAuto is super handy. It'll automatically format text based on the size of your screen and the output of the rows. So it's nice and readable. But down here, the set slow queries, you can name queries and just run this then inside your session. So it's super handy that you don't have to remember all these crazy queries. You can just set them up once. Then any database you ever connect to, you have them accessible. So really quickly, a couple of basics on how data retrieves. Hopefully this is super boring to everyone, but I thought I'd set the stage at least a little bit before we talk more about indexes. There's essentially two ways it's going to access data in Postgres. You're going to have, the first type is the sequential scan. Here, what it's going to do is start searching the data on disk just in order until it finds what you're looking for. So if you're looking for, where record ID equals 3, it's just going to start searching until it finds that. Although it's going to keep searching all records if you don't have a limit there. The other big way is index scans, and there's a variety of type of indexes. So I'm going to show the super dumbed down. Under the covers, they work so much more intricately than this. But basically, a B-tree index is going to keep, this grouping go here, traverse down, and eventually know how to get down to this record. An important thing about indexes in Postgres, before 9.2, they always had to hit disk if you use an index. Postgres under the covers is one big append-only log. It just keeps writing data. So when you delete data, it's writing data. And basically marking it as dirtied. So it knows on disk that it's dirtied, but the index may not be updated. So it would always have to hit disk to know if that's the case. 9.2, it gets a little better with index-only scans. They're great. They can be performant. It's magic when they work, and when they don't, good luck figuring out why they're not working. But kind of the rough rule of thumb, when you're looking at your database, optimizing, what do you care about? Sequential scans, they're good for large reports, so they're not always bad. If you're reporting on your whole data set, you want it to be doing a sequential scan, not looking at a record and going to disk for every single one. Also, if you're computing over thousands of rows, usually they're pretty good. Index scans, most web applications you want using an index. Hopefully you're not returning hundreds of thousands of rows in a page in your web application. And it's going to be the most common queries in your app. So cool. So how do you actually take a specific query and look at performance of it? Given a really basic query, you can put explain in front of it, and it's going to give you something like this. Does anyone actually understand the output of that? One hand. OK. It's actually not that bad. There's kind of 3 values in there that you care about. Or there's 3 values in there and 2 that you really care about. Why are they separated by 2 periods? I don't know, because that's perfectly intuitive. So you've got cost, which is the startup time. You've got the max time that it thinks it'll take to return this query, and then the rows returned. The thing you really care about there is the max time. And if you put explain analyze in front of a query, it's going to tell you what it thinks it's going to do. So explain says, hey, here's how long I think this is going to take and the plan I'm going to execute. If you do explain analyze, it's actually going to tell you how long it took and what it did. So there you see the estimates kind of grayed out, the actual stuff, and then the actual time it took to run. So rough guidelines, I would say for most applications, page response times less than 100 milliseconds. Common queries, you want to take less than 10 milliseconds. And I actually generally aim for around 1. Not perfectly under 1 second, but kind of in that ballpark. Rare queries under 100 milliseconds. And again, these aren't like BI reporting queries, just less common queries in your application. So looking at that, you can see my actual time is 295 milliseconds. Pretty easy to fix this. Since I'm filtering on salary, the obvious thing is let's try adding an index on salary and see what happens. And it does come down to 1.7 milliseconds. So this is great if you've got like a problematic page. But for a lot of people, they're just like, hey, how do I fix things in my database? What's slow? Do you want to look at every single page? If a user's complaining about a page, yeah, that's great. Dig in and look at the queries. But you don't want to necessarily wait for users to complain. PG stat statements is absolutely amazing. If you're not using it, you should be. It's the single best kind of visibility thing in Postgres. It was in Postgres for a while and crappy, and in 9.2 it actually became useful. So what it does is normalize every single query that's run against your database. What I mean by that, if I had this query select star from users where email equals Craig at Heroku, it's going to swap out Craig at Heroku and put in that question mark. It's going to track every single time it's run, how long it takes to run on average, and all of this crazy stuff about like which buffers are dirtied, which ones are written, all this sort of stuff. Most of this stuff you don't have to care about. Really, you just need to have this query, which is going to give you the most expensive queries on your database in aggregate. So this is like which query consumes the most time from the history of my database, and then on average, how long does that take? So it looks something like this. So from there, I can get that query text and say, all right, this is a crappy query. I want to go optimize it. Coming back to the, how long should a query take? I probably wouldn't optimize the first one because I wouldn't start there. Just because 10 milliseconds, I may be able to get down to 1. But 80 milliseconds, if I get down to 1, I'm getting 2 orders of magnitude back and saving quite a bit of overall time for my system. So shifting a little bit onto indexes. Postgres has quite a few indexes. Even if you read the docs, your reaction may be something kind of like this. Really, really rough rule of thumb. When you do create index, you're doing a B-tree index. This is usually what you want. You can do it. It works. Unless you're doing something interesting and trying to dig in a little bit more with Postgres, you're safe here. If you are doing interesting things, How many people here are using hstore? Okay, that's a pretty good show of hands. How many people here aren't familiar with it? That's also a pretty good show of hands. Well, I'll talk a little bit more about it in a minute, but essentially if you're using hstore or the array data type, if you've got multiple values in a single column, genindex is the type you want to use. Just indexes can be helpful there too, but there's back and forth trade-offs. One's bigger on disk, one's a little faster in certain cases. Rough rule of thumb, gen for array and hstore. If you're using full text search or like PostGIS or some of the polygon shapes, gist is the type you want to use. The way it's kind of described to me is that if you've got values that can overlap in multiple ways, like shapes can, or text values can across different documents, it's the right thing to use. So a few other ones. K-nearest neighbor is for similarity. Space partition gist. Now I'm probably at the point of having this been described to me 50 times by like Postgres core people, and the only thing I know it's good for is phone numbers. Yeah. And then vodka is something that's coming. So kind of an interesting detour. Some of the people that commit a lot of things to Postgres, they're all over the world. But there's a group lovingly known as the Russians in the Postgres community. And they work at the University of Moscow. One's actually a professor of astrophysics and just commits things to Postgres in his spare time. And they go in, they show up on the list and have these crazy ideas for indexes and optimizations and new data types. People are like, that sounds crazy, it won't work. They go into a cave for 6 months, and they come out and have like all these new indexes types. So like gen, gist, knn, spgist, and vodka, all from them. When you ask them about it, their general reaction is, it is good, just commit. And people do, and it works. You can guess where vodka came from. They had gin, and they're Russian, and that's the working name. I'm not sure how I feel about it going in, but I don't know if we're winning that battle. I think it's actually a space partition gin index, as I understand it, which means I still don't know what it is good for. So a little more on indexes. There's a few other types. I don't necessarily know how to classify the types, so just like there are other types. Conditional, functional are the other two. Hopefully these do what you would expect. So a condition. The example here, if you've got like a white pages, yellow pages application, or I guess white pages, and people live multiple addresses over their lifespan, and you want to keep all of them, but people aren't searching on where I lived 3 years ago. They're searching on where I live now. You could have where current address is true. So basically just put your condition on the index, and it'll index, where only that value applies. So if you've got a ton of data but only want to index a subset of it that's important, this is pretty easy to do. Functional. So given a query, so I've got some JSON data and a function to grab the numeric value for this key. It's doing the exact same as the other one. I'm just doing a function now on the data. So here I can create an index across all of it. An important thing on functional indexes, if your data returns the same value when passed into the function, I'm not sure if that should sound crazy or not. If the same input always returns the same value out, put a mutable on it. It basically means the function can't randomly change your data or do random things, which apparently people do this because this is a supported functionality. But put a mutable on it when you create it, just so Postgres knows how to optimize it. So here you just create an index on the function like you'd expect. Hopefully no surprise here, you can combine them. So we can have conditional and functional together. And one other thing, create index concurrently. This shouldn't quite be the default in every ORM, but it should be really close to it. If you're running a large production website, and if you've run certain other databases, that when you add an index, it holds a lock, possibly for days while it adds that index. Postgres doesn't require you to do that. Adding concurrently onto create index will execute it in the background, and then as soon as the index is created, it'll swap over and start using it. So it's about 2 to 3 times slower. I say it doesn't hold a lock. That's not 100% true. It holds a lock for about 2 or 3 milliseconds. But essentially, there's no kind of long lock on the table, so you can keep running your website in production. So hstore and JSON. So quite a few hands went up, unfamiliar with what hstore is. hstore is hands down the best data type in Postgres. It's a key value store inside Postgres. So Postgres has this thing called extensions. It's this weird middle ground where it's inside the core of Postgres, but also not turned on, and you have to enable it. And there's ones that aren't shipped with Postgres, but you can manually install, and then you still have to enable them. hstore is one that's in that middle ground where it's shipped with Postgres. You've just got to turn it on. So you basically run create extension hstore, and then you have this new data type. And it's a key value store inside your database. So it's not a full document store. It's only keys and values, but it's nice and handy. So you can just start shoving stuff in there. I think data is actually a pretty good name for a column that I'm throwing random things into. I have people complain about that at times, but it works pretty handily. And there I can just insert whatever I want. So I can add new keys, new values. I can search on those. I can filter on those. I can say where this key exists or doesn't exist, where this key has this value, and it's pretty nice. So in 9.2, Postgres got JSON support. I imagine everyone heard about this. If not, you were probably living under a rock. The unfortunate thing is that JSON support is pretty useless in 9.2. I kind of hope you're not using it. All it does is validate your text as valid JSON. There's no good performance to it. It then throws it into just a text store. In 9.3, it got a little better because there's actually operators where you can search and filter on values of it. But essentially what it's doing right there is taking a text string and converting it to JSON, the JSON type. The database is just doing that under the covers. So hstore is really, really awesome because those crazy index types I talked about from the Russians. So hstore is from the Russians. And those crazy index types, gen and gist, work on hstore. So adding a gen index is going to index everything in the hstore, so it's just going to be fast. You don't have to worry about it. So JSON with 9.3, you can now do functional indexes, but have fun because you're creating all these functions and indexes on all different kinds of variations of your JSON, which is kind of painful. JSON-B just got committed to Postgres 9.4. The world is going to be so much of a happier place now. It's really getting close to like a full document store. So it's binary JSON on disk. It's fast, it's performant. It was actually a collaboration of some Postgres people in the US and, surprise, surprise, the Russians. But yeah, if you, in their words, like, it is good, just commit, use it. Gen indexes now work on this, which is great. Gist will be coming. So you get all that awesome performance that you had with hstore just out of the box. So a little bit on pooling. How many people here run a connection pooler? So that's probably bad, except for you're probably using one and not realizing it. I'm pretty sure Active Record does by default. SQL does by default. There's a couple layers of it. So application framework layer, you pretty much don't have to worry here because Aaron and others have your back of just making it work. The other option is a standalone daemon. So even with an application level connection pooler, at a certain point, you're going to, hopefully, if you're successful and have hundreds and hundreds of connections to your database, you want to use an application layer one. There's two options here, PG Bouncer, PG Pool. So I'd say once you started getting to the point of 200 connections to your database, adding something like PG Bouncer is really, really good. PG Pool, I don't know that I'd recommend. It does a lot of things kind of okay. PG Bouncer does one thing really well, which is pooling. Adding cache. So as I mentioned, an easy way to scale up your database is throw more memory at it. It's really the easiest way to solve database performance problems. You should do indexes and other things too, but adding more memory helps. But sometimes you can't go up anymore. So one interesting option is scaling out. There's a variety of ways to do this. You can start sharding, which is more complicated. But you can also just have replication and send all of your read queries to something that's lagging behind by 1 second. That's mostly fine for all web applications. So when you start looking at replication, there's a few options. These have been around for a while: Sloaney, Londiste, Bicardo, PG Pool. These are a little newer. Wally and Barman use these. Wally is a project out of Heroku. We use it on all of our databases, so if you're on Heroku, you already have it running for you. It works on Amazon, it works on Azure, it works on Rackspace. It works pretty much everywhere. And Barman. So these are tools to essentially help with taking Postgres' write-ahead log, archiving it somewhere, and then setting up a replica so that you can query from it. The really nice thing about replicas and sending different queries there is each Postgres database is going to have its own cache and optimize for it. So one nice trick you can do is specific models you could send to a specific database, and it's going to optimize for that. So instead of sharding, you can kind of get away a little bit easier there than having to figure out a more complicated sharding model. Backups. Does everyone here take backups? Does everyone here test them? Okay, then you probably don't have backups. Really, test your backups. If you don't, the number of times that I think every DBA person has not tested backups, went to restore, and they're completely screwed. Talk to a DBA, they have a horror story like that. There's a couple types of backups. So logical, this is probably what you're doing. This is when you run pg dump. It's human readable, it's portable. It can be in raw SQL, you can compress it to another format. There's also physical backups. If you're doing replication, you're probably doing this. So if you're using Wally or Barman, it's also known as a base backup, and it's actually the physical bytes on disk. So it's not cross-platform friendly. I can't take one and just ship it somewhere else. I have to have the exact same architecture. I hear rumors that it maybe works across some architectures, but it's super not supported by Postgres. So if it works, it's just lucky, and you should expect it to break. And so backups actually do have an impact on performance. Logical is good across architectures, but I would say it's really good for just like dump export. It does some nice things of checking for corruption as well, but there's other ways to do that. But it's not going to scale. So generally, Postgres starts falling over on PG dump at above 50 gigabytes on a database with load. So if your database has no load, great, you can continue backing it up. But it does also have a good bit of load on the database itself. So as soon as you take a PG dump, it's going to start to slow down your performance. Physical backups are definitely what the community starts to encourage once you're at a certain scale and size. A little more initial setup. Wally, Barman help with this. They're less portable, but limited load on the system. They work to huge scale. You can throttle them and just kind of manage them in a more granular fashion. I thought I'd be so much slower being it's 7 a.m. San Francisco time. So a quick recap. As I mentioned, OLAP, BI, data warehousing is a whole other talk. They are essentially disk I/O is important, and the order on disk is really helpful. There's this crazy tool, PG Reorg, out of NTT Telecom that like live reorders stuff on disk, and it's great if you use it right, and if you don't, you have the ability to wipe everything in your database. They're working with the core community to get some of these bits into core Postgres so it's safer. It's super promising. But then also MPP solutions. So there's a ton of databases that emerge out of Postgres. It's a great foundation to build on. Adding it as a column restore. And if you're really getting into the data warehousing space, you can start to look at some of these solutions. I think Redshift is based on an MPP solution par excel from 5 years ago. So a lot of the big players are Postgres-based at some point, though they've deviated pretty far. And then for OLTP apps, ensure the bulk of your data is in cache and that you have a good cache hit. Search for cache hit in Postgres. Hopefully you find my blog, and if not, you'll find a query that works. Look at overall load with PG stat statements. If you have a problematic page, yeah, look at the explain plans and add some indexes. But looking at it from a macro level with PG stat statements is a really good way to just get some power back from your database. Efficient use of indexes, hopefully that's obvious. And when cache sucks, really the easiest way to scale a database is just throw more money at it. So if you're doing all these other things, it's perfectly fine to keep scaling up memory. Great, thanks. Any questions?